In February of 2025, a Chinese carmaker walked onto a stage in Shenzhen and announced a battery that could take a car from 10% to 80% in 5 minutes. Not 50 minutes, not 15, 5. That is roughly the amount of time it takes to fill a gasoline tank, pay at the counter, and walk back to your car. For the entire history of the electric vehicle, that number was supposed to be impossible. Charging was the wall. Charging was the reason your uncle refused to buy an EV. And then a company that most Americans could not have picked out of a lineup 10 years ago casually walked up to that wall and put a hole straight through it. The car was the BYD Han L, and the numbers attached to it read less like a product spec sheet and more like a dare. Over 1,000 kilometers of range on a single charge under Chinese, more than 1,000 horsepower from a family sedan. 0 to 100 kilometers per hour in around 2.5 seconds. A charging architecture running at 1,000 volts, pushing a peak of 1 megawatt of power into the battery pack, and a starting price in China that sits somewhere in the neighborhood of $27,000 US. Read that last part again. A 4-door sedan that out-accelerates supercars, drives from Beijing toward Shanghai without stopping, and refills faster than most people can finish a coffee for the price of a mid-trim Toyota Camry in America. Something has clearly shifted, and it did not shift slowly. It shifted the way a dam shifts, quietly holding for years and then giving way all at once. If you find these deep dives useful, hit the like button and subscribe. It genuinely helps these videos reach more people, and there is a lot more coming on this exact topic. Now, the story of how this car exists is not really a story about one car. It is a story about batteries, about factories, about a country that made a very specific bet 20 years ago and refused to blink. To understand why the Han L matters, and why it made a lot of very expensive engineering departments in Detroit, Stuttgart, and Palo Alto have a very bad week, we need to go back to the problem that has haunted electric cars since the very beginning. The problem was never that electric motors were bad. Electric motors are, mechanically speaking, beautiful. They have almost no moving parts. They deliver full torque instantly. They do not need a gearbox with 7 forward gears and a clutch and a transmission fluid change every 60,000 miles. Anyone who has ever driven a golf cart or a forklift knows that electric drive is smooth and immediate in a way combustion engines simply are not. The problem was always energy storage. Gasoline is an absurdly good way to carry energy. A single gallon of it holds roughly the same usable energy as an entire suitcase full of lithium cells did back in the 90s. And you can pour gasoline. You can move it through a hose at 15 gallons per minute. Try moving energy into a battery at that rate, and the battery gets hot, then it gets angry, then it degrades, and in the worst cases, it does something you really do not want happening under your seat. So for decades, the electric car was stuck in a triangle. You could have range, or you could have speed of charging, or you could have affordability. You could usually get two, almost never all three. Early electric cars in the 1990s had lead-acid packs and could barely manage 100 kilometers. The first generation of lithium cars in the 2000s stretched that, but charging still meant an overnight stop or a very long lunch. Even as recently as a few years ago, a genuinely fast charge on a mainstream EV meant around 30 minutes to get most of the way full, and that was considered excellent. 30 minutes does not sound terrible when you read it. It sounds catastrophic when you are standing in a parking lot in the rain in February, watching a progress bar, with 2 children in the back seat asking how much longer. That gap, that 30 minutes versus 5 minutes, is the entire psychological difference between an electric car being a lifestyle adjustment and an electric car being simply a car. And that is the gap BYD went after. But before we get into how they closed it, you have to understand who BYD actually is, because almost nobody outside of China does. BYD does not stand for anything glamorous. The company was founded in 1995 Shenzhen, by a chemist named Wang Chuanfu, and it did not make cars, it made batteries. Small ones, the kind that go into mobile phones and cordless drills and camcorders. Wang had studied metallurgical physical chemistry and had worked at a government research institute studying battery materials, and he noticed something that changed everything. At the time, Japanese firms dominated rechargeable battery manufacturing. Their production lines were fully automated and cost tens of millions of dollars to build. Wang could not afford that. So instead of buying the machines, he broke the process down into dozens of small manual steps and hired workers to do them by hand with simple jigs and fixtures. His startup capital was a loan of about $300,000 from a relative. Within a few years, BYD was undercutting the Japanese giants on price by enormous margins and supplying batteries to Motorola and Nokia. That origin story is not a fun bit of trivia. It is the whole key to the company. BYD has always looked at an expensive industrial process and asked whether it could be rebuilt from first principles, cheaper. Every single thing that makes the Han L possible traces back to that instinct. In 2003, BYD bought a struggling state-owned car company called Xinchuan Automobile. The investment community hated it. The stock dropped sharply. Analysts asked why a battery manufacturer with real profits would voluntarily walk into the automotive business, which is famously brutal and capital-intensive and dominated by century-old giants. Wang's answer was simple and, in hindsight, extremely obvious. He was not entering the car business. He was entering the battery business at a much larger scale. A phone battery holds a few watt-hours. A car battery holds tens of thousands. If electric cars were ever going to happen, whoever controlled the cells would control the industry. He was not buying a car company. He was buying a customer for his own factories. Then he waited. For years, BYD sold conventional gasoline cars that were, frankly, not very good. Copies of Toyota designs, cheap interiors, the kind of vehicle that fills taxi fleets and does not get written about. Meanwhile, the battery division kept grinding forward, iterating chemistry, cutting cost, learning manufacturing. Warren Buffett's Berkshire Hathaway bought a 10% stake in 2008 for about $230 million. Charlie Munger described Wang Chuanfu as a combination of Thomas Edison and Jack Welch. At the time, that sounded like an old man being generous. It does not sound generous anymore. But the breakthrough that put BYD on the map came in 2020, and it involved rethinking not the chemistry of the battery, but its shape. Here is the situation they faced. There are two dominant lithium chemistries in cars. One uses nickel, manganese, and cobalt, and it stores a lot of energy in a small space, which is great for range. The catch is that it uses cobalt, which is expensive, mostly mined in the Democratic Republic of the Congo, under conditions that make headlines, and it is thermally less stable. Push it hard, and it can enter what engineers politely call thermal runaway. The other chemistry is lithium iron phosphate. It contains no cobalt and no nickel. It is dramatically cheaper. It lasts far longer, often several thousand full charge cycles instead of several hundred, and it is extraordinarily stable. You can abuse it in ways that would make the other chemistry ignite. The catch was that it stores meaningfully less energy per kilogram, which meant shorter range or a heavier car. For years, the industry treated that as a settled trade-off. Premium cars used nickel chemistry. Budget cars and buses used iron phosphate. End of discussion. BYD refused to accept the trade-off and attacked it from a completely different angle. If the chemistry stores less energy per kilogram, they reasoned, then stop wasting so much space around the chemistry. In a traditional battery pack, individual cells are grouped into modules, each with its own housing and hardware. Those modules are then bolted into a larger pack with its own structure, cooling, and casing. It is a Russian doll of packaging, and every layer of packaging is dead weight and dead volume. In many packs, only around half of the total volume was actually doing the work of storing energy. BYD's engineers designed long, flat cells, roughly the shape and size of a blade, and stood them side by side directly into the pack structure, like books on a shelf. No modules. The cells themselves became part of the structural rigidity of the pack, and the pack became part of the structural rigidity of the car. They called it the blade battery. The result was that a chemistry with lower energy density per kilogram suddenly delivered competitive energy per cubic meter of car. Volume utilization jumped enormously. The pack got thinner, which lowered the floor, which improved the interior. It got stiffer, which improved handling. And because the cells were long and flat, they had far more surface area to shed heat, which improved safety and charging behavior. To prove the safety point, BYD publicly ran the nail penetration test, which involves driving a steel spike straight through a fully charged battery. A conventional nickel pack in that test can reach temperatures over 500 degrees Celsius and burst into flames. The blade battery, in BYD's demonstration, produced no fire and no smoke, and surface temperatures stayed low enough that an egg placed on top did not cook. That test video did more for BYD's credibility inside China than any advertising campaign could have. And it set up everything that followed. Because once you have a pack that runs cool and handles abuse, you can start asking a much more aggressive question. How fast can we shove power into this thing? That question is where the Han L stops being an evolution and starts being a genuine shock. The physics of charging is not complicated at the surface. Power equals voltage multiplied by current. If you want to move more power, you either raise the current or you raise the voltage. Raising current is the easy, dumb option, and it fails quickly because current is what generates heat in a cable. Double the current and you quadruple the heat loss. That is why ultra-fast chargers already need liquid-cooled cables with coolant pumped through the wire itself. So the smart path is voltage. Most electric cars for the last decade ran roughly 400-volt architectures. A handful of premium models moved to 800 volts, which was considered cutting-edge and expensive. Because every component in the car, every inverter, every relay, every bit of insulation, has to be rated for it. BYD went to 1000 volts, and they paired it with a battery pack and cooling system designed to accept peak charging power of 1 megawatt, 1,000 kilowatts. To put that in perspective, an average American home draws somewhere around 1 to 2 kilowatts on average. A single car, for a few minutes, pulling the equivalent of hundreds of homes. They branded the system Super E Platform, and the marketing line was blunt and effective. 2 kilometers of range per second of charging, roughly 400 kilometers added in 5 minutes. Now here is where a lot of coverage stops, and where the interesting part actually begins. Because there is an enormous problem hiding inside that number, and BYD had to solve it separately. Where does a megawatt come from? You cannot simply install a 1 megawatt charger on a random street corner and plug it into the existing grid. The local distribution transformer would not survive the conversation. Most public charging sites in the world are limited not by the car and not by the charger hardware, but by the size of the electrical service coming into the property. Upgrading that service can take years of utility negotiation and cost more than the chargers themselves. BYD's answer was to build the buffer into the station. Their flash charging stations incorporate their own stationary battery storage. The station slowly sips power from the grid at a rate the local infrastructure can comfortably handle, stores it, and then dumps it into the car in a violent 5-minute burst. The grid never sees the megawatt spike. It sees a steady, boring, manageable load. That is a genuinely clever piece of systems thinking, and it is only possible because BYD makes stationary storage batteries too. A company that only made cars could not have done this. A company that only made chargers could not have done this either. And then they committed to building 4,000 of these stations across China and announced partnerships to open the network to other manufacturers' vehicles. Which brings us to the comparison everyone actually wants to make. For more than a decade, Tesla defined what an electric car was supposed to be. That is not a controversial statement, it is simply history. Tesla proved that an EV could be desirable rather than penitential. It proved that software-defined vehicles could improve after purchase. And critically, it built the supercharger network, solving the chicken and egg problem that had killed every previous attempt at electrification. The Model S was, and in many ways still is, an excellent car. The Model 3 and Model Y became among the best-selling vehicles on the planet. Tesla's manufacturing innovations, the giant single-piece castings, the structural pack, the obsessive cost engineering, forced the entire industry to move. But look at the timeline. The Model S launched in 2012, the Model 3 inches 2017, the Model Y in 2020. The Cybertruck arrived in 2023 into a segment that was not exactly starving, and the fundamental architecture underneath the volume products has been iterated rather than replaced. Tesla's superchargers currently peak around 250 kilowatts on most of the network, with a next generation pushing higher. Tesla's cars mostly run 400-volt architecture. Tesla's range figures, measured under the stricter American EPA cycle, land in the 300 to 400-mile band on the best variants. Now, an honest note here, and this matters because a lot of videos on this topic quietly skip it. The 1,000-kilometer figure for the Han L comes from the CLTC, the China Light Duty Vehicle Test Cycle. CLTC is generous. It assumes lower average speeds and gentler driving than either the European WLTP standard or the American EPA standard. As a rough rule of thumb, a CLTC figure often lands somewhere around 20 to 30% above what EPA would report for the same car. So, 1,000 CLTC kilometers is realistically something in the region of 700 to 800 real-world kilometers, depending heavily on speed, temperature, and how enthusiastic your right foot is. That is still a very large number. It is still more than most people drive in a week, but it is not magic, and anyone telling you it is a straight 1,000 kilometers at highway speed in winter is sickling you something. The same honesty applies to the 5-minute charge. Peak charging power is not sustained charging power. No battery accepts a megawatt from 10% all the way to 80%. The curve tapers, and it tapers hard as the pack fills. The 5-minute claim is measured under near-ideal conditions, with a preconditioned battery, on BYD's own hardware, at a station specifically built for it. On a cold morning, on a third-party charger, at a busy site where the station's buffer battery is already depleted from the previous 3 cars, your experience will be different. But here is the thing. Even if you cut every one of those numbers substantially, they are still extraordinary. Even a heavily discounted version of these specifications would have been considered science fiction in 2019. And the direction of travel is what should frighten the incumbents, not the specific figure on the press release. Because the real weapon here is not range or charging speed at all. It is the price. $27,000, roughly, in the domestic Chinese market. That is not a promotional lease. That is not a stripped base model that does not exist on any dealer lot. That is the price of a car with 1,000 horsepower and 1,000 kilometers of claimed range. How is that possible? The answer is vertical integration taken to an almost obsessive extreme. BYD makes its own battery cells. It makes its own battery packs. It makes its own electric motors. It makes its own power electronics, the inverters and converters that manage energy flow. It makes its own semiconductors, including insulated gate bipolar transistors, through a dedicated subsidiary. It makes its own displays, it makes seats, it makes lighting. Estimates suggest that BYD produces something around 3/4 of the components in its own vehicles in-house, at a time when most legacy automakers produce well under half and function primarily as designers and assemblers, sitting on top of a sprawling supplier network. Every one of those suppliers, in a traditional automaker's chain, takes a margin. Every one of them adds a negotiation, a logistics link, a point of failure, a delay. BYD collapsed the entire chain into one balance sheet. It goes further than that. BYD secured stakes in lithium mining operations. It operates its own fleet of ocean-going car carrier ships because when it decided to export seriously, it discovered that global shipping capacity for vehicles was booked solid and expensive, so it simply commissioned its own vessels. That is not normal behavior for a car company. That is the behavior of a company that has decided bottlenecks are unacceptable. And underneath all of it sits the labor and scale advantage of manufacturing in China, plus 2 decades of Chinese industrial policy that poured enormous state support into electrification, subsidized purchases, mandated charging infrastructure, and made new energy vehicles a national priority long before Western governments treated them as anything more than a niche. You can have opinions about that industrial policy. Plenty of people in Washington and Brussels have very strong ones, but you cannot argue with the outcome. In 2024, BYD sold more than 4 million vehicles. It overtook Tesla in total battery electric sales in the final quarter of that year, and it has been outselling Tesla overall for some time when plug-in hybrids are counted. It surpassed Volkswagen as the best-selling brand inside China, ending decades of foreign dominance in the world's largest car market. For a company that was making phone batteries by hand 30 years ago, that is an almost unbelievable trajectory. So, what does this mean outside of China? In Europe, BYD is already selling. The Dolphin, the Seal, the Atto 3 are on roads in Germany, Norway, the UK, and elsewhere. The company is building an assembly plant in Hungary and another in Turkey, which is the standard playbook for getting inside a tariff wall. In Brazil, Thailand, Australia, Israel, and across Southeast Asia, BYD has moved from unknown to top-selling in a remarkably short time. In the United States, BYD passenger cars are effectively absent, and that is not an accident. Tariffs on Chinese electric vehicles were raised to a level designed specifically to make importation pointless. The stated rationale mixes trade fairness arguments about subsidies with national security concerns about connected vehicles collecting data. Whether you find that justified or protectionist probably depends on where you live and what you drive, but it is worth being clear-eyed about the consequence. Blocking a product does not make it worse. It just means your domestic industry gets to compete against it later, on foreign soil, with less practice. Ford's chief executive has spoken publicly about driving a Chinese electric car and not wanting to give it back, and has been unusually blunt in calling Chinese competition an existential threat rather than a distant concern. That is not a man engaging in marketing. That is a man reading a spreadsheet. There is a reasonable counterargument here, and it deserves airtime rather than dismissal. Building a fast car with a big battery is one thing. Building a car that still feels solid after 8 years and 150,000 miles is another. Legacy manufacturers have spent a century learning about corrosion, about seals that do not leak in the 12th winter, about suspension bushings that do not turn to mush, about dealer networks and parts availability, and warranty logistics. Those things are boring and invisible, and they are exactly what determines whether a brand survives. Chinese brands are young by that standard. Long-term reliability data is thin. Crash safety ratings in European testing have generally been strong, which is a meaningful signal, but resale value, parts supply outside China, and software support over a decade are genuine open questions. Anyone who buys purely off a spec sheet is making the same mistake buyers made in the 1970s when the first wave of imports arrived, and some of them rusted spectacularly. And there is a second counter-argument. Domestic competition inside China is currently brutal to the point of being unsustainable. Dozens of brands are fighting a price war with negative margins, and several have already collapsed, leaving owners with orphaned vehicles and no software support. Consolidation is coming. BYD is very likely to survive it, given its scale and its component business. Many others will not. None of that changes the core fact, though. The technological ceiling has moved, and it moved from a direction the established industry was not seriously watching. Think about what actually just happened in engineering terms. A battery chemistry that was written off as the cheap option, suitable only for buses and budget cars, got repackaged so cleverly that it now underpins a car with supercar acceleration and sedan practicality. A charging speed that the industry treated as a decade-away goal arrived on a production vehicle, and the grid limitation that everyone assumed would gate that charging speed got solved by putting a battery inside the charging station, which in hindsight is so obvious that it is slightly embarrassing nobody deployed it at scale first. That is what real innovation usually looks like. Not one miracle, a stack of unglamorous, practical decisions made by people who owned every layer of the problem and therefore could change any layer they wanted. There is a broader lesson buried in this story that goes well beyond cars. For most of the last century, the assumption in industrial economics was that advanced manufacturing was something wealthy countries did, and low-cost manufacturing was something developing countries did, and the gap between them was permanent because it was built on decades of accumulated engineering knowledge. Cheap and sophisticated were treated as opposite ends of a single axis. What has happened in the Chinese automotive sector over the last 15 years is the collapse of that axis. The same operation that delivers low cost is now also delivering technical leadership in specific domains, because scale itself became the engine of learning. You do not get better at building battery cells by reading papers. You get better by building hundreds of millions of them and watching what fails. Whoever builds the most learns the fastest. That is the entire mechanism. It is not mysterious. It is just uncomfortable if you stopped building. And it should make you wonder what else is quietly following the same curve. Solar panels already did, almost entirely. Lithium refining largely has. Grid-scale storage is heading the same way. Drones, in the consumer and commercial segments, went there years ago, and hardly anyone noticed until it mattered. Electric buses and commercial trucks are moving now. The Han L is not really the story. The Han L is the receipt. So, where does this leave an ordinary person who just wants a car that works? Honestly, in a better position than they have been in decades. Competition of this intensity is uncomfortable for manufacturers and excellent for buyers. Prices are falling. Charging speeds that were premium only 2 years ago are trickling into mainstream models. Every incumbent automaker now has a very concrete reason to stop treating electrification as a compliance exercise and start treating it as a fight for survival. Some will rise to it. Several major legacy brands have already restructured their entire electric programs in response, partnering with Chinese firms for platforms and software rather than trying to build everything themselves, which would have been unthinkable to admit 5 years ago. Others will not rise to it, and in 10 years, their badges will be owned by somebody else. The interesting question is not whether Chinese electric vehicles are good. That question is settled, and pretending otherwise is just comfortable. The interesting question is what happens when a technology that is genuinely better and genuinely cheaper collides with trade barriers built to keep it out. History suggests that walls buy time and nothing else. What matters is what you do with the time. 20 years ago, a chemist in Shenzhen bought a failing car factory that nobody wanted, using money made from selling phone batteries assembled by hand because he believed that whoever controlled energy storage would eventually control transportation. Investors called it a mistake. The stock fell. He was simply early. And the car sitting in Chinese showrooms right now, with 1,000 kilometers of claimed range, 1,000 horsepower, a 5-minute charge, and a $27,000 sticker, is what being early looks like once the waiting is finally over. The rest of the industry is not behind on one product. It is behind on 20 years of decisions. And decisions like that cannot be bought back with a press conference or a tariff. They can only be caught up by building, at scale, for a very long time, starting immediately. Some companies have already started. Some are still writing strategy documents about it. We will find out fairly soon which is which. If you got something out of this breakdown, hit subscribe. Every week, we take apart the technologies and industrial shifts that are quietly rewriting the global balance of power, the ones that get a single paragraph in the news and then reshape entire economies. There are related videos on screen right now. And a genuine question for you before you go. If a Chinese electric car appeared at your local dealership tomorrow, undercutting everything else by 30% with better specs and a real warranty, would you actually buy it? Or does where a car comes from still matter to you? Tell me honestly in the comments, because I suspect the answers are going to be more split than anyone expects.